Welcome to part 2 of trying to get the 18FQ20 chip family working. So this is the new chip family. Trying to get the 18F26Q24 operational, and this is what I'm calling the ADC challenge. I'll give you the concept, I'll give you the issues. So I've already published 2 videos, so I've moved forward to the next video, which is setting the LEDs to represent the value of the ADC. So I sort of do that before I do the video number 2, and then I quickly do that and prepare it all, and then just leave it for a day. Normally, it looks like it's all sequential. Of course, it's not. Over the years, there's always a problem, and this is what the problems are. And this is the deep dives. Okay, so compilers, open source, APIs, LGTs, etc. And what we've got is this core compiler, and I've sort of added some red bits in here to say there are certain things going on inside the chip that need to be understood, documented in source code or in the libraries, and or the chip dat file at the bottom there in red is changed, and it needs to be absolutely configured. It's configured because I'm not, hopefully not changing the compiler itself. And that in just to get the LEDs working, I had to correct the dat file because the dat file production was wrong. That's been corrected, and now the LEDs are working. The memory was incorrect. So this is around what are the problems of introducing a new chip. So I've got a board. This is my board. It's got on it, oh, I don't know why it's zoomed out. It's got on it lots of stuff. Here's the Q24 sitting here. PICKit2 program here. PICKit2 is not the problem, never is. Works fine. LEDs are connected through these flying leads into port B.0. We saw a discussion of that. And I've now hooked up the pot here, a little pot, look. And that's a reset, by the way. Look, it's randomly doing things because we're going to look at the source code. And what we want to do is, as I rotate the pot, have the 4 LEDs there represent the value of the pot. And so that's all we're trying to do. It's quite simple. Trying to get the ADC to show the results on the LEDs. So in the context of we are doing a set of demonstrations, I'm going to introduce things here to debug that really do come a lot later in the demonstrations because I'm trying to build slowly on the capabilities, not to throw everything at a user. And so we start doing LEDs, a bit of ADC, a bit of switches. And it's all about inputs and outputs. But in reality, to fix it, we need to go deep really quickly, okay? Very quickly. So how do I go about doing that? So the first thing I do is I have a program, and I've taken this program from all the other demos. They're all the same in reality. And all this does, okay, here's my little diagram I've created. I better put my ADC on here, look. I've got an ADC on here. There we go. ADC on A0. You can put it elsewhere. I don't really care where you put it. LEDs on here. VDIO is on here. And I've got all my constants. And so basically all this does, it defines a byte, reads the AD on that particular channel, AN A0, puts it into that value. And there's a case statement in here or something. Oh, look, it's really clever. Look, it basically says if the value is some value, then put a number of different LEDs on. It's not hard. Function key F5. I'll go to Zen mode, what I call Zen mode, so I can see what I'm doing on the screen and on the program at the same time. And it's just erasing it and it's programmed it. Great. So what have I got? I've got a screwdriver here. Look at that. Look. I rotate the pot. Nothing happens. You go, that doesn't look right, does it? So what I'm going to do is I'm going to take ADC val, and I'm very quickly going to make a quick hack in this program to do some testing, okay? So ADC val equals 0. Oh, I know how to do it. There's a better way. Watch this, look. For ADC val equals 0 to 255, take that line out, put a next at the bottom, and now what it will do, it will just loop through every 100 seconds, and it will just prove that the compiler is doing its funky stuff in terms of compiling the source code, the for next loop, setting variables. Because it could be a memory issue still. I don't know what the issue is. Well, that has surprised me. Wow. Oh no, it's setting it. Look, it was just doing a bit slower than I thought. I was doing a bit slower. The four LEDs are setting, so it tells me that the logic inside the compiler, not the DAT file, the compiler is handling do loops, for loops, etc. correctly. I can see that because the LEDs are coming on and they're incrementing through exactly as if it was the pot. All right, that's really good. That's a very good test. Very quick way to confirm things are good. So inside of my source code, I might as well get rid of that for next loop because it doesn't prove anything. It didn't help me. The thing's quite clearly in the function of ReadAD. And beyond that, at the moment, I don't know where it is. So I'm going to stop the video, do some hunting around. And once I figure out where it is, I shall start again on the next part of the video. I'll come straight back to the video because there's something I should do straight away. I'm going to put the serial value, I'm going to put the value of ADC val onto the serial terminal. I should do that because it just confirms that it's not reading it properly, if that makes sense. So when it does read it properly, I can see the results. So we're going, in my demos, this is like demo 10, but we need to get there very quickly. So what I've done, I've nipped out to MPLAB. Here's MPLAB. Always the tea leaf. In English, that means always up for a laugh. Here is MPLAB, and I created a project here called Q24, and I in MCC I have asked it to put the serial output on a port. Okay, so I've said to it, give me RC5 as RC6, sorry, as the transmit, and RC5 as the receive, and that is in that source code there in MPLAB. I'm just going to steal it. Watch this, look. I'm going to steal that, and I'm going to plonk that in my source code. Now, insight. Sticking it there doesn't make it work. What will happen is that the chip will initialize, it will set up the memory, and it won't have initialized the serial port because it needs to initialize the serial port before it's used. And if you're debugging stuff, libraries get called before the serial is initialized. As weird as that sounds, that's the way compilers work. You've got to put it in the right place in memory. So what we do is, many people have seen this, hash startup, and I'm going to call PPSInit, and I'm going to hand crank this one. I call it hand cranking, PPSInit, and it will set the PPS, one of the first things it will do. And we'll have a look at that in a minute in sub. And we're going to look at, just indent it a little bit. And all I've done is taken C code and shoved it in there. Okay, F6 just to compile the code, make sure it works. Great, that was fine. And now we're going to look at the assembler. Function key F7. Open up the assembler. There it is, the assembler. This is all the stuff we're going to come into later to figure out why it's not working. What is important, you understand, is this, is that the program runs and it comes to this vector here called org0, and it essentially goes to program start because there's no interrupt. If there was an interrupt, it would be slightly different, but for now, org0, the next instruction is go to program start. So it's BAS program start, always the same. This address could change depending upon what's happening, but we're going to go to here. It runs in its sys, then it runs PPSInit, then it goes into our program. Now, what is important is that the position of that is controlled, and you can move that up and down. Not many people do this. You can move that up and down in the start order. Watch this like that. If I wanted to make the PPSInit the first thing that happened, I'd put a (0) behind it. I think it defaults to 85. F6, just compile the code. people see 85 in there, they don't really know why they're doing it. And now, oh look, PPSInit has been shuffled up the code. So think of init sys as 50 in out of 100, and you can sort of move things about. You can reorder things in the initialization process by putting that comma behind it, specifically that start. And if you have lots of libraries, you might need to order them. Okay, so you can shuffle things about. So I will revert that because that's normally it would go at 85. So in my program, I've got init sys, I've got my PPSInit, and now I'm just going to put on the screen a command. 8 serial print a byte, and the one I'm going to put out is ADC val, and it will then put my result on the screen every 100 milliseconds. Still won't work because we're bodging this up, remember? We need to put in the initialization for the serial underscore USART. It will automatically put it in if you do that. I don't know if I've ever typed that in 5 years now, because even in the old editor, it could do this stuff. Start up the terminal. I'd already got it hooked up to my, there it is, it's operational, and I'm going to program it. Function key F5, and inside my little terminal here, we're going to see some results. Zoom in. Do you see the results? No, we got no results because the cable's come off. Let me just connect that to, does anyone remember what it was? C6 or C5? C6. I'm just putting on the TTL here on the board. A bit of stress. Oh, there we go. Great. And you might go, hey, it's not connected. It is, trust me. All right. Let me go to Zen mode. There's the results. Look, get my big screwdriver out. Rotate. Now this should go to 0 when it's there, and it ain't working. Something's not working. I will check my connection. Oh, I've got it on A1. That's why. I've got it on A1. Hey, the vagaries are testing, eh? Have I got it? Oh, look at that, look. It works out the box, look. Nothing needs changing. That's brilliant. Oh, I'm impressed by that. I'm impressed by that. Oh, that's good. That's pretty cool, that. It's all right. I'm impressed myself. Hey, it works. Let's just go back into here, into my source code. Oh, wow. We can do some other tests whilst we're here then. Change that val to a word. Change that to a 10. Is this a 10-bit? Does anyone remember? Function key F4 into pick info. Open up data sheet. Actually, my PowerPoint might tell me if it's a 10-bit because I should have written it down in my PowerPoint. No, it doesn't show me. $10-bit. So it's a 10-bit, so I'm expecting a value between 0 and 100 and 1023. So I'm going to print that value on the screen, and because that only prints bytes, change that to. So this just, so because AD10 is a different set of functionality, so you just need to, I need to test both because it wouldn't be valid otherwise. And that's sort of doing, now the LEDs won't be correct because the range is incorrect, but on the terminal we'll get hopefully 0 to 1023, and we do. And that tells me that the ADC is working out of the box. No changes required. That means I can, good job, I came straight back to put the terminal on there, wasn't it? And check my connections, check the connections. So no issue. So in my PowerPoint, and I'm knocking up here, I can come into here and go ADC initially no results, a wrong connection on test rig. Okay, what a fool. There we go. So I'm going to go over and now do demonstration 3, which is all about putting LEDs. Now I'll take out all the serial stuff, all that stuff will be taken out, and I will just do the basic test, which was, if I look at my video list here, sequence the LEDs, set the LEDs to represent the value of the ADC, and I would stop it there. So that's what I'm going next, okay? Back in my PowerPoint, you've seen this diagram, don't need that. This is all about getting the basics going. Enjoy.